You are on a cruise ship in the middle of the Pacific Ocean. No land in sight, and you're on a video call. No lag, no buffering, just internet. Or you're 35,000 feet in the air on a transatlantic flight and you're streaming Netflix. This is what Starlink does. And in the last 4 years, it's connected more than 6 million people in places the internet had essentially given up on. But how does this flat box the size of a large pizza actually pull this off? And is it actually better than what you already have at home? Starlink is SpaceX's satellite internet service. It was founded in 2015, that's when the development began, but it was not until 2018 when it launched its first 2 test satellites, called Tintin A and Tintin B, and the service finally went into public beta testing in late 2020. The basic idea sounds almost too simple. Put thousands of small satellites in low Earth orbit around Earth and use them to beam internet down to anyone on the ground with a dish. But the execution of that idea is what makes Starlink impressive, but expensive and somewhat controversial. Traditional satellite internet have relied on massive satellites sitting in what's called geostationary orbit. That's about 35,000 kilometers above Earth. At that altitude, the time it takes for a signal to travel from your device up to the satellite and back down is about 600 milliseconds, over half a second for every single time. For browsing, it's annoying, but for video calls, basically unusable. Starlink's answer was to go much lower. Their satellite orbits at around 550 kilometers, that's roughly 60 times closer to the Earth than geostationary satellites. At that altitude, the signal round trip takes just 20 to 40 milliseconds. That's in the same range as a decent home broadband connection. At 550 kilometers, a satellite has to circle the entire Earth in about 90 minutes. It's constantly moving, so you can't just point a dish at a fixed spot in the sky. This is why Starlink doesn't use 1 or 2 massive satellites. As of early 2026, there are over 10,000 of them in orbit, forming a continuous mesh across the sky. Your Starlink dish, which users have affectionately named Dishy, is a flat panel with hundreds of tiny antennas, often known as an electronic phase array antenna. It's electronically steered, automatically tracking whichever satellite in the constellation gives you the best signal at that moment. The signal goes from your dish up to the satellite, then either to the ground station or, here's the really clever part, directly across to other satellites via laser link in space before coming down to the internet backbone, known as the optical inter-satellite links. Those laser links mean Starlink can route your data entirely through space, making it faster than undersea cables for intercontinental traffic. Light travels faster through a vacuum than it does through glass fiber. Now, in-flight internet. Before Starlink, in-flight Wi-Fi was essentially a joke. You pay $15 for a connection that struggled to load a web page, let alone handle a video call. Starlink aviation is different. Airlines mount a flat electronically steered antenna on the top of the fuselage. The installation adds minimal aerodynamic drag. The antenna continuously tracks the Starlink constellation even at 900 km per hour, 35,000 feet up. Speeds of 135 to 450 megabits per second for the entire aircraft, enough for every passenger to stream 4K video simultaneously. As of 2026, more than 40 airlines have signed up or are actively rolling out Starlink. United Airlines plans 800 plus aircrafts by end of 2026. Emirates is equipping its entire 232 strong wide-body fleet by 2027. Virgin Atlantic began flying with it in May 2026. The IGA Group, that's British Airways, Iberia and Aer Lingus, has 500 aircrafts being fitted. Let's put Starlink into proper context. How does it stack up against every major type of internet connection that came before it? Dial-up. The 1990s, you'd plug in a phone cable to your computer and wait for that iconic screeching sound. Maximum speed, 56 kilobits per second. Downloading a single high-res photo took 4 minutes. A 3-minute song could take 10. Then broadband in the early 2000s. Cable and DSL speeds of 1 to 25 megabits per second. A step change. You could stream music, browse without waiting, and eventually watch standard definition videos. Then came fiber optic. Light literally pulsed through the cables. Speeds of up to 1 gigabit, that's 1,000 megabits. latency as low as 5 milliseconds, the gold standard. Then there was cellular. 3G could barely handle loading YouTube videos. 4G let you stream comfortably. 5G in dense urban areas now competes with fibre, hitting above 1 GB with latency as low as 10 milliseconds. And now Starlink, speeds of 100 to 250 megabits per second typically, latency of 20 to 40 milliseconds, not as fast as fibre, not as low latency as 5G in a city, but faster than most home broadband, and available almost everywhere on Earth. Fibre needs physical cables in the ground. 5G needs towers within a few kilometres. Both are expensive to build, and rural areas almost always come last. Starlink has no such limitations. So what does it actually cost? This is where people might be a little hesitant to spend, especially if they have a broadband or fibre optic connection. The hardware, the dish, router and cables, runs at $349 for the standard residential kit. There's also a mini dish for $249, designed for travel, camping and vehicles. Plans in the US start at $55 a month as of 2026, going up to $130 a month for the top tier plan with maximum speeds and network priority. The most popular mid-tier runs at about $85 a month. In some regions where satellite capacity is limited, there are only one-time congestion fees on top of that, ranging from $100 to $1,000. And in markets outside of the US, pricing is set locally and can look very different. To put those numbers into perspective, if you live in a city with access to fibre optic internet, Starlink looks like a terrible financial deal. The national average for a fibre connection sits right about $85 a month. But for the same $85, fibre gives you up to a gigabit of speed. That's roughly 5 times faster than Starlink, with a virtually zero upfront equipment cost. But is Starlink's real competition fibre optic? Starlink does have its own limitations. First, weather. Rain, thick cloud can cause real signal degradation. Because Starlink relies on high frequency radio waves, moisture in the atmosphere physically absorbs and scatters the signal. Recent European network studies show that even a moderate rain shower can instantly slash Starlink's overall throughput by nearly 20%. If a severe torrential storm moves in, the atmospheric block gets so thick that download speeds can crater, leading to sudden buffering or brief dropouts entirely. For someone who already has fibre buried safely underground, that kind of weather vulnerability is a deal breaker. Second, congestion. When too many users share the same satellite in a given area, speeds drop and latency spikes, particularly during peak evening hours. This is most noticeable in suburban areas where Starlink has grown fastest. Third, the night sky. Astronomers and space agencies have raised serious concerns about Starlink's 10,000 satellite constellations polluting the night sky. The satellites create bright streaks across telescope images and complicate space traffic management at a time when Earth's orbit is already getting crowded. To fight this, SpaceX has invested in re-engineering their hardware, using advanced mirror films to scatter light and programming the satellites to pivot knife edge to the sun so they remain mostly invisible to the naked eye. And fourth, the Elon factor. Whether you view him as a visionary or a liability, the man behind Starlink is now one of the most polarizing figures on planet Earth. In 2025, several European governments debated cutting Starlink's contracts, raising concerns about data sovereignty and the risk of a single private operator controlling critical communication infrastructure globally. For people in cities with fibre, Starlink is a curiosity, an interesting backup, something you consider for a cabin in the mountains. But for billions of people in rural areas, on ships, in remote clinics, in developing nations, Starlink isn't a luxury. It's the first real broadband that they've ever had, but at a severely high cost. Starlink crossed over 6 million customers by mid-2025 in over 150 countries. 42 new countries came online in 2025 alone. The company plans to get close to 12,000 satellites in orbit by the end of 2026, seeking regulatory approval for putting up more gradually. So is Starlink better than fibre? No, not if you have it, but it's close, and for millions of people around the world, this may be the only option they have available to them.